NASA's James Webb Space Telescope has to stay super cool to observe the cosmos. How does it beat the heat? Black paint. As the agency explained in its new YouTube series Elements of Webb, the James Webb Space Telescope's radiator is painted black to absorb heat. Just like how black asphalt gets hot in the summertime, objects that are black are generally hotter as they absorb all wavelengths of light and convert it into heat. Comparatively, white objects reflect light and do not absorb heat. Webb engineers use this principle to keep the telescope cool. Webb essentially has two sides, a hot side and a cool side, which is separated by the spacecraft's sun shield. The cool side is where its highly sensitive scientific instruments reside, and sun shield blocks any heat from the sun from reaching those instruments. The cool side even has a radiator to keep it extra cool, NASA multimedia specialist Sophia Roberts said in the video. That radiator and everything except Webb's bright gold mirrors are black on that side, she explained. Now, this black paint is important, not only because black objects absorb heat well, but also because they emit heat well, Roberts noted, adding that objects painted black are highly emissive, a measurement of how well something radiates heat. To ensure that the black paint used on Webb did the best job possible at soaking up and radiating heat away from the telescope's instruments, NASA used a special ultra-black paint made by Ball Aerospace called Ball Infrared Black, or BIRB. Webb's cold side is about -388 degrees Fahrenheit or -233 degrees Celsius. So why do Webb's instruments need to be so cold? Webb observes primarily infrared light, which we humans perceive as heat. If the telescope is too warm, that heat could interfere with observations. Since the scope's instruments naturally create heat as they work, Roberts noted, Webb has to be proactive about cooling off. This is why, in addition to shielding the instrument from solar rays with the sun shield, Webb also has a radiator, painted with BIRB, that helps keep things as chilly as possible. Webb arrived at its final home in space on January 24th after a month of traveling nearly 1 million miles through space. By observing in infrared from this distant vantage point, scientists hope that Webb will be able to peer back at some of the earliest moments in the universe's history, detecting the heat from the earliest stars and galaxies to ever exist. Webb will spend its lifetime at L2. It was previously thought that the observatory might operate for just 5 to 10 years in space, because of its limited propellant supply and the fact that it was not intended to be refueled. However, after launch, the mission team now expect that Webb will have a significantly more than 10-year science lifetime, thanks to the job that Ariane 5 did on launch day, NASA officials wrote in a post-launch statement. The thing is, if you really want to be up to date with the James Webb Telescope, this isn't enough on its own. There's actually more to this story that you definitely haven't heard about before. That's why you really shouldn't ignore this video here, because it's going to take what you've just learned and make it 10 times more powerful, maybe even 100 times. A head-on collision between galaxies has created a vast, cosmic triangle in deep space, glittering with star formation in a new image captured by the Hubble Space Telescope. The new photo, which NASA released on Tuesday, February 22nd, showed a pair of colliding galaxies known as ARP-143. Arranged in what scientists described as a space triangle that's spawning a tsunami of star birth by sharing gas and dust, according to the Hubble team statement. The two galaxies in this system collided head-on, fueling the triangular-shaped burst of star formation, Hubble officials wrote in the image description. The pair contains the distorted, star-forming spiral galaxy NGC 2445 at right, along with its less flashy companion NGC 2444 at left. This wave of star birth produced by the collision, officials added, appears to be rare due to the triangular shape of star formation visible in the image. Part of the reason for that shape is that these galaxies are still so close to each other, and NGC 2444 is still holding onto the other galaxy gravitationally. Participating astronomer Juliana Dal Canton of the Flatiron Institute Center for Computational Astrophysics in New York and the University of Washington in Seattle said in the Hubble statement. Dal Canton added, NGC 2444 may also have an invisible, hot halo of gas that could help to pull NGC 2445's gas away from its nucleus. So they're not completely free of each other yet, and their unusual interaction is distorting the ring into this triangle. Adding complexity to the collision is NGC 2444's propensity to pull away strands of gas from the other galaxy, creating streamers of young, blue stars bridging the two galaxies. The streamer stars were created between 50 million and 100 million years ago, and will be stuck in space as the galaxies continue to pull apart from each other. Another set of young stars, only 1 million to 2 million years old, is also forming in the heart of NGC 2445. Meanwhile, NGC 2444 is only filled with older stars. It lost its gas before the collision occurred, astronomers said. The collision provides a fantastic sandbox to understand star formation and interacting galaxies, Elena Sabe, a scientist at the Space Telescope Science Institute in Baltimore, added in the statement. Corkscrewing through the cosmos, three distant galaxies collide in a stunning new image captured by NASA's Hubble Space Telescope. This cosmic crash is known as a triple galaxy merger, when three galaxies slowly draw each other nearer and tear each other apart with their competing gravitational forces. Mergers like this are common throughout the universe, and all large galaxies, including our own, the Milky Way, owe their size to violent mergers like this one. As chaotic as they seem, mergers like these are more about creation than destruction. As gas from the three neighboring galaxies collides and condenses, a vast sea of material from which new stars will emerge is assembled at the center of the newly unified galaxy. Existing stars, meanwhile, will survive the crash mostly unscathed, while the gravitational tug-of-war among the three galaxies will warp the orbital paths of many existing stars. So much space exists between those stars that relatively few of them are likely to collide, Live Science previously reported. Adding complexity to the collision is NGC 244's propensity to pull away strands of gas from another galaxy, creating streamers of young, blue stars bridging the two galaxies. The streamer stars were created between 50 million and 100 million years ago, but will be stuck in space as the galaxies continue to pull apart from each other. Another set of young stars, only 1 million to 2 million years old, is also forming in the heart of NGC 2445. Meanwhile, NGC 2444 is only filled with older stars. It lost its gas before the collision occurred, astronomers said. The collision provides a fantastic sandbox to understand star formation and interacting galaxies, Elena Sabe, a scientist at the Space Telescope Institute in Baltimore, added in the statement. The thing is, if you really want to be up to date with the Hubble's telescope, this isn't enough on its own. There's actually more to this story you definitely haven't heard about before. And that's why you really shouldn't ignore this video here, because it's going to take what you've just learned and make it 10 times more powerful, maybe even 100 times.